3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at NASA's exploration ground systems. Within only a few years, NASA's Space Launch System is set to take off and send humans back to the moon for the first time in over 50 years. However, the SLS launch vehicle is not the only piece responsible for such an incredible feat. In order to launch such a powerful rocket consistently, NASA has constructed and continued to work on massive amounts of infrastructure. NASA's Exploration Ground Systems, or EGS, is the backbone of future missions to the moon and beyond. There are many different pieces that contribute to future launches, including crawler transporters, the mobile launcher, and Launchpad 39B. All are extremely complex and necessary pieces of equipment for any future launch. NASA has put a lot of work into each aspect of the ground systems to ensure future success. While rockets often get most of the attention, the infrastructure can be just as interesting. These machines and complexes have to move and support one of the biggest and most powerful rockets in the world. These intense requirements have helped shape their design and purpose. If we want to not only send humans back to the moon but set up a more permanent human presence, different exploration ground systems are necessary. What exactly are the exploration ground systems? The EGS is one of 3 different programs based at NASA's Kennedy Space Center in Florida. The purpose of the exploration ground systems is to develop and operate the systems and facilities necessary to process and launch rockets and spacecraft during assembly, transport, and launch. NASA is also in the process of trying to transform these necessary ground systems to be available for different rockets, and not only government use, but commercial as well. In the past, with launch vehicles such as the Saturn V or the Space Shuttle, the ground systems were developed and built specifically for each rocket. This has some limitations on what is capable in the future. The current exploration ground systems are planning to be used for the Space Launch System, along with future launch vehicles. The reason NASA is working towards future infrastructure available for government and commercial use is related to long-term sustainability and affordability. With different government and commercial customers, it will distribute the cost among multiple users, lowering the cost to access space and increasing launches. With this goal in mind, NASA is upgrading a lot of key components, including Launchpad 39B, the crawler transporters, vehicle assembly building, the mobile launches, and more. Exploration ground systems key components. Crawlers. The first main component of the exploration ground system I want to talk about is the crawler transporters. Launch vehicles such as the Space Launch System are not constructed and assembled on top of the launchpad. Instead, they are often assembled nearby in a specific large building designed for this task. However, this brings up the issue of moving an almost 6 million pound 384-foot tall rocket. To solve this problem, NASA has developed and built massive machines called crawlers. These behemoth machines have carried the load of taking rockets and spacecraft to the launch pad for more than 50 years at NASA's Kennedy Space Center in Florida. The crawlers are about the size of a baseball infield and are powered by both locomotive and electrical power generator engines. These crawlers were originally built in 1965 with the purpose of moving the Saturn V. Years later, the crawlers were used to transport the Space Shuttle for 30 years. They now are expected to move the Space Launch System for future missions to the moon. Specifically, Crawler Transporter 2 will be integral to the Artemis program. The crawlers weigh about 6.6 million pounds and stand at 20 to 26 feet tall. Arguably the most impressive stat is the 18 million pound load capacity, enough to carry 20 fully loaded 777 aircraft. Mobile launcher. The next piece of equipment that is vital within the exploration ground systems is the mobile launcher. The mobile launcher is the ground structure that will be used to assemble, process, and launch NASA's SLS rocket and Orion spacecraft from Launchpad 39B. When preparing for the launch, the crawler transporter that I mentioned prior will pick up and move the mobile launcher into High Bay 3 in the vehicle assembly building. The mobile launcher consists of a 2-story base that is the platform for the rocket, and a tower equipped with a number of connection lines, called umbilicals. These different features will provide everything needed for the launch process, including power, communications, coolant, fuel, and stabilization prior to launch. Lastly, the tower has a walkway that extends to the crew module, allowing personnel and astronauts to access the rocket. When everything is ready, the mobile launcher on top of the crawler will make its 8-hour trek over 4 miles to the launch pad. From here, engineers will remove the crawler transporter and lower the mobile launcher onto the pad. Launchpad 39B. The last main component of the exploration ground systems that plays a major role is Launchpad 39B. Currently, NASA is hard at work preparing this launch pad for the upcoming Artemis missions. The pad is ready for the first Artemis mission, where an uncrewed Orion spacecraft will launch atop the Space Launch System and go beyond the moon and back to Earth. However, the agency is working on multiple upgrades for future Artemis missions with humans. Specifically, work is in progress on a new liquid hydrogen tank and emergency egress system for Artemis 2, the first crewed launch. As I mentioned prior, a lot of these components have been used for decades. For this reason, NASA is upgrading and changing different aspects to ensure future smooth and successful Artemis missions. Pad subsystems, for example, that were used for Apollo and the Space Shuttle program have been either upgraded or replaced for SLS. When making these changes to the Launchpad, NASA has been using the guiding principle of clean pad. This has to do with the goal of launching many different types of future launch vehicles. Launchpad 39B has multiple unique features that are built and designed to handle massive amounts of power and force from launch vehicles such as SLS. These features include electrical power, a water system, flame trench, and safe launch area. The water system alone has a peak flow rate of 1.1 million gallons per minute. All help not only launch the rocket, but keep it and the surrounding area safe. Any other needs of individual rockets, including access for workers, can be met with the towers or other structures that deliver the rocket to the pad. Apollo 10 was the first mission to begin at Launchpad 39B when it lifted off May 18, 1969. Now, more than 50 years later, NASA is working towards sending the next era of humans to the moon. Conclusion. A rocket is an extremely complicated piece of technology and engineering. NASA has put a lot of time and effort into the next launch vehicle taking humans to the moon, SLS. However, the Space Launch System cannot launch by itself. NASA has worked on and upgraded the exploration ground systems that facilitate a successful launch. They do this with the crawler transporters, mobile launcher, and Launchpad 39B. All work together to assemble, move, and launch the massive rocket headed for the moon. These different machines and infrastructure are crucial for Artemis and more commercial missions in the future. We will have to wait and see each component's success and the impact it has on NASA's goal for the moon and beyond. Thank you very much for watching.